All right, this is the still the first set of notes, but it's the second video. It's going to cover starting with the page that's marked arc and chords. Okay, a central angle. Okay, so let me make sure I get the pencil turned on here. A central angle is an angle whose vertex is the center of a circle. So basically what you got going on is anything that comes out of the center of the circle is a central angle. That would be this would be, as long as the center is the vertex, you've got a central angle. An arc is an unbroken part of a circle consisting of 2 points called the endpoints and all points on the circle in between. So you're going to put arc there, and it's spelled A-R-C. So basically, an arc, let me use a blue color just to have something different on the page. This blue piece of the circle right here would be called an arc. An arc is basically part of the circumference, okay? So an arc is part of the circumference. It's a piece of the distance around the circle. So that's one helpful way to remember it. Okay? All right. Okay. So now if you look down, let's see. Remember, I'm trying to think what goes in this little blurb here. Remember, a circle has what? I don't know. 360 degrees. I didn't see the little degree mark. So a whole circle is 360 degrees. So half of the circle would be 180 degrees. We can measure arc length in as like part of the whole. We can, use an instrument. You could use a measurement like inches or meters or something like that. And sometimes we even use degrees to kind of talk about parts of it. Let's go on and label these other pictures here. A minor arc is an arc whose points are on or in the interior of a circle. Kind of think of it this way. That little minor arc there is between A and C. There's two arcs in this first picture. One of them is the red AC. So this is the minor one. It's kind of shorter. That might help you think about minor being shorter. In the same picture, they've highlighted the other arc. On the next picture, it's the same circle, but the red thing labeled there is your major arc. It goes, it's on the outside of the points that are on the circle. So if it's on the inside, it's a minor arc. Outside, it's a major arc. If the endpoints of an arc lie on the diameter, the arc is 180 degrees. Okay, so we can talk about it that way. It's a semicircle. There's different ways we can talk about this. Most of the time we're going to call that just a semicircle. So we know that's 180 degrees because it's half of the whole circle. The whole circle is 360 degrees. 360 divided by 2 is 180. Okay, the last thing on this page, it says minor arcs may be named by 2 points. So notice when they named this arc up here, if I'm trying to see how big that arc AC is, first of all, I can talk about AC by just saying it goes from A to C, directly from A to C. And that would be X. Okay, so I'm having issues here with that would be X degrees. Okay. Now over here, the other piece, if you notice this arc, it should have this over it also. If I want to name a major arc, I have to do it by naming 3 points. I have to say go from A to C, but you got to go through point D. So you have to name this one with 3 letters. So if you've got a major arc, you cannot name it with 2 letters. You have to use 3 letters. You have to say it starts at A, goes through D, and goes to C. Now if I wanted to know what that measurement is, it's almost the whole circle, right? It's the 360 degrees, but I got to take out however much X was. So I could write it like that. I could subtract X from the whole circle, 360 degrees, and that would be the measure of the minor arc. The measure of arc EFG, and really this should have that little arc mark over it. And because it's half a circle, we're going to go ahead and use the 3 letters, EFG, to talk about a semicircle, just so we know which side we're on, of the circle. This is going to be 180 degrees because it's half of the circle. So remember, minor arcs may be named by 2 points. Major arcs and semicircles must Must. It's not an optional thing. It's not right if you don't name it by all 3 letters. Must be named by 3 points. Okay, so if you're looking at the top of the next page, we're still talking about arcs in a circle. And if we have an adjoining arc, are arcs of the same circle that intersect at exactly 1 point. So if you look at the picture of here to the right, the red arc and the blue arc, they're right next to each other. They're, you might even, you could think of them as adjacent to each other. So sometimes you may even use the word adjacent arcs. But they share the point S, so that's the 1 point they share. And so what we get from that, you remember in line segments we had the definition of betweenness, where we could say if we have a point between 2 other points, we could say, if I add those 2 parts together or split at the point where they join, I'd have the whole thing. Well, it's the same thing here. I can say, for instance, with the one that's over here that's not in the box, I could say the measure of arc RST, I might write just to make sure. That still looks like a minor arc to me, but I might want to write it that way just so I can write it's the measure of arc RS plus the measure, there should be a plus sign, measure of arc ST. And if you look, you see the S, one ends at S and then the other one picks up at S. So right here they've marked it for you in the box, arc addition postulate. So that's something you could put in your proof book. The measure of arc ABC is the measure of arc AB plus the measure of arc BC. So moving down to number 5 here, they say find each measure. So if I want to find measure of arc BD from B to D, if I want to find out how long that is, here's what I can do. I can have vertical angles on arcs the way that I just have them with regular angles. So if this piece right here is 97.4, this one right here is vertical to it, so it will be 97.4. Now, if I want to know BD, though, I need to know, that's degrees, I need to know what CD is. Now, if I want to find CD, I'm going to have to look at something a little different here, because I want to say that BD is equal to arc BC plus arc, which this would show up better, arc CD. Okay. So now I can figure out what CD is. I'll put a red dot on it because if you look at it, it's part of this semicircle right here. Let me circle the whole thing. So if that whole circle is 180 degrees, if I could just subtract out the 52, that would give me 128. And then I subtract out the 97.4. I could find out what's left in that semicircle, and that's what this arc CD would be. So 128... let's see, that would be 6.6, 0, and 12 minus 9 is 3. So it would be 30.6 right here, okay, where I'm drawing the dot to. So if I want to know the whole thing, it would be 97.4 degrees plus 30.6 degrees. One thing that gets kind of confusing about arcs is that I can talk about them in terms of degrees, and I can also talk about them in terms of a measurement. So you'll see us do that at a little bit later date. Kind of wanted to warn you that's coming because that seems to confuse people. So if you know from the beginning that I can measure in degrees and I can also measure another way, that's just kind of good to keep in mind. Now 4 and 6 is 10, so that's going to be 0, carrier 1. 7 and 1 is 8. 9 and 2 is 128. So measure of arc BD that got left off, it just didn't print, is 128 degrees. So I'm going to write it over here. Altogether, that makes 128 degrees. If I want to know what AB is, AB, let me use, since I'm drawing on the same document here. Actually, let me erase. Okay, if I want to know the measure of AB, AB is a vertical angle to all of this right here. And I knew earlier that DC ended up being, oh goodness, I've lost track of what DC was. I think it was 30.6. Okay, so DC is 30.6 here. So that piece is 30.6, and if I add 52 to it, that would be this whole angle right here. And that would make the whole thing 82.6. And that's what AB would be 82.6. So let me write that in, 82.6 degrees. Okay, so I can, we're going to measure in degrees right now.